All right, sixth grade, we talked a little bit about area and perimeter, and we've talked about rectangular figures, and we've also talked about circles. And now what I want to do is review with you area of triangles and parallelograms. And I think you've seen this before, but what's really important to me is that after this video, you can explain not just what are the formulas for finding the area of these figures, but where do those formulas come from. So what I want to do now is just look at this, and this is just why we talked about base times height. That's what makes sense for finding the area of a rectangle. And the reason that makes sense is because we can think of this as just seeing that we have 6 centimeters as a height and 10 centimeters as a base. Well, that means we have 10 centimeters or 10 units from one side to the other. But we don't just have 10 units, we know that we use centimeters squared. So how many groups of 10 units are we going to have? Well, we need to have 6 groups. We're going to have 6 different layers of this 10 centimeter length. And so we're going to have these 10 centimeters in the first row, we'll have 10 centimeters in the second, 10 centimeters in the third, fourth, fifth, and sixth. So that's just kind of looking at 6 groups of 10 centimeters squared. And we know that when we're thinking of multiple groups of repeatedly adding, that's when we have multiplication. So we know that base times height makes sense for a rectangle, but what about for parallelograms, which we talked about today, or what about triangles? And what we first have to do is we first have to look at parallelograms, and hopefully it's easy to see that these look pretty familiar, or similar, I should say, pretty similar to rectangles. Now, we know that it looks a little bit different. It looks like it's slanted, you may say, but this length is different from the normal height that we've been using. Instead, our height goes vertically through the middle. But what's really nice is for all parallelograms, we can kind of take this little extra chunk that goes further beyond the height, and we can move it to this extra space where we don't have any area covered in. And if we do this now, we can, just kind of think of erasing the spot that we just moved over and we just filled it in. Now it just looks like just a normal rectangle. The important thing to realize, though, is if we're going to find the same area, we can do base times height, but we're ignoring the length of this diagonal. So for finding the area of a parallelogram, we don't want to use the length of this diagonal, the side length, we want to use the height. Base times height will work just like it did for rectangles. Now, once we can understand that about parallelograms, we can also see something cool that happens when we have a triangle. And the cool thing that happens is this. It looks kind of different. It looks different from rectangles. We can't really compare them yet. But what we can do is if we double the triangle and flip it over. Oop, I overturned that one. If we double it and then turn it over and then connect, what do we have now? Well, now we have a parallelogram. And we have a parallelogram that has a base that's the same as our triangle, and it also has a height that's the same as our triangle. So we know that a parallelogram, as we just showed ourselves, we could find the area of this entire parallelogram by multiplying base times height. Well, then what would each of the triangles have as an area? Well, each of the triangles would have half of that. So we could do, for the formula for area of the triangle, this triangle is going to be half the parallelogram, or 1/2 times the base times the height. So those are the two formulas that you need to know. We're going to put those into practice and take notes on them right here, but right now I just want you to see kind of where they come from. So here are the notes we need. Area is the measure of space taken up in 2 dimensions. We already had that definition, but I want you to see it again. What is a base? A base is a side with a perpendicular height. So we saw in the parallelogram we had 4 different sides, 2 sets of opposite sides. The base was the one that the perpendicular, the height was coming from, and heights are perpendicular, which means they join at a right angle. That's why for rectangles we don't need to draw a new height. The side is at a right angle, so the sides are just the heights. So base is a side with a perpendicular height. What is the area of a parallelogram? Area of a parallelogram is 1/2, area of a parallelogram is the base times the height. Area of a triangle is 1/2 times the base times the height. And finally, area is always measured in square units or units squared. So that's another repeat note that I need you to remember. Let's look at some practice problems. This first one is calculate the area, and this, of course, hopefully you can recognize as a parallelogram. So we know that the area of a parallelogram, and this is how I kind of like to to show what I'm finding. Area of a parallelogram, and that's not perfectly done, but that's okay, is the base times the height. What's our base and what's our height here? Well, this could be a base and this could be a base, but we know that the base is wherever the height is coming from, and this height is perpendicular to the bottom and the top. So 21 meters is actually our base. What's our height then? Our height is 5 1/3 meters. Alright, if you remember multiplying mixed numbers, we need to make these into improper fractions. So 21 over 1 and 5 1/3. Well, each of these 5 has 3/3, and then I have 1 extra third. So 5 times 3 is 15, plus 1 is 16 thirds. Now before I multiply top times top over bottom times bottom, I can simplify as I go. I'll divide that by 3, I get 1. Divide this by 3, I get 7. 7 times 6 is 42, carry a 4. 7 times 1 is 7, plus 4 is 11. So this is 112 over 1. Any number over 1 is itself, so it's 112. And we know that if you multiply meters times meters, that's meters squared. Area is measured in meters squared. So we just knocked it out right away. I hope you noticed, though, that we didn't have to use 7.8. It was neither the base nor the height. It was just a different side, and we didn't need that. Let's look at another problem. This is a triangle. And we know that the area of a triangle, we just derived it or figured it out with a picture, and then we just wrote down the notes. So the area of a triangle is going to be 1/2 times the base times the height. Now in this case, I was making it a little bit more difficult for us, or a little tricky, I guess I should say, to try and figure out which is the base and which is the height. So hopefully you can take a moment and figure that out for yourself. And you'll see that the base has to be 10 meters. It's not always at the bottom, it's not always at the top. It's wherever the perpendicular is coming from, and we can see this right angle shows us this is a perpendicular. So the height was easier to pick out probably, and it's 2.5 or 2.5 meters, and our base though is 10 meters. So what do I want to multiply first here? Well, I know that multiplying a decimal with one decimal place by 10 is really nice, because whenever we multiply by 10, our place value shifts and our decimal kind of moves to the right. So this is going to be 1/2, and 10 times 2.5 would be 25. So 1/2 times 25, we can do that mentally. What's half of 24? That'd be 12. And then we need half of one more because we have 25. So it'd be 12.5 or 12.5, whichever way you want to write it. 12.5, and this is again meters squared because we're talking about area. So we need square units to cover a flat two-dimensional space. Hopefully these made sense to you. I hope that that little picture explanation made sense. I'm going to leave you with some problems to work on your own. So check it out. The first one says, find the area of a parallelogram with bases of 9.5 inches, other sides of 12.35 inches, or 12 3/5 inches, and a height of 8 inches. So make sure you just use the numbers that you need. And then we have this triangle here with side lengths of 9 feet, 14 feet, and 14 feet. And then this perpendicular in the middle is 7 feet. So do your best, and I'll check those tomorrow.